Good morning, class 11. Let's start. Heavy water. Now, the molecular formula of heavy water is D2O. Ordinary water contains small proportion of D2O. Hence, it can be prepared by prolonged electrolysis of water or by fractional distillation. When water is electrolyzed, H2 is liberated much faster than D2, and the remaining water becomes enriched in heavy water. If process is continued for a long period of time, almost pure D2O is obtained. We come to the physical properties of heavy water. Physical constants of heavy water are higher than that of the ordinary water because molecular mass of heavy water is more than that of the ordinary water. Dielectric constant of D2O is slightly lower than that of H2O. Therefore, ionic compounds are less soluble in D2O than in H2O. We move to the chemical properties. Reactions of D2O are slightly slower than that of H2O. First, action with metals. D2O reacts with alkali and alkaline earth metals slowly to liberate deuterium. Sodium reacts with D2O to form sodium deuteroxide plus deuterium. Similarly, calcium will also react with D2O or heavy water to form calcium deuteroxide and deuterium. Right? Next, we move to action with metallic oxides. Basic oxides of metals like calcium, sodium dissolve in D2O to form respective deuteroxides. Like calcium oxide will dissolve in D2O to form calcium deuteroxide. Okay. Next, action with the non-metallic oxides. Non-metallic oxides like phosphorus pentoxide, sulfur trioxides, etc. readily dissolve in heavy water, forming corresponding deuteroacids. Phosphorus pentoxide dissolves in D2O to form deuterophosphoric acid. Similarly, sulfur trioxide will dissolve in D2O to form deuterosulfuric acid. Okay, next, action with metal carbides, nitrides. Aluminium carbide reacts with D2O to form aluminium deuteroxide and deuteromethane. D2. Okay. Next, magnesium nitride reacts with D2O to form magnesium deuteroxide plus deuteroammonia. Sorry, Mg3. This is Mg3N2. Sorry. Okay. Next, electrolysis. On electrolysis, heavy water decomposes to give deuterium and oxygen, which are liberated at cathode and anode respectively. Okay. So, if I write the reaction like D2O undergoes electrolysis, then what do I get? I get deuterium at cathode and oxygen gas liberated at anode. Okay. Next is exchange reactions. When compounds containing hydrogen are treated with D2O, hydrogen undergoes exchange for deuterium. For example, NaOH, when treated with deuterium oxide, that is D2O, we get NaOD plus HOD. Okay, so these are the following reactions under heavy water. Next, we come to uses of heavy water. First one, heavy water has been used in nuclear reactors as a moderator because it slows down the fast moving neutrons and therefore it helps in controlling the nuclear fission reactions. Heavy water is used as a reference in nuclear magnetic resonance spectroscopy that we call as the MRI. It is used as a reference in the MRI. Okay. Next, we move to the hardness. Now, first of all, we'll be talking about hard water, soft water. Now soft water are the waters which readily forms lather with soap solution. Okay, for example, rainwater, distilled water, etc. And hard water are those which does not form lather with soap solution readily. For example, we have tap water, river water, sea water, etc. Now the cause of hardness of water. Hardness of water is due to the presence of dissolved bicarbonates, chlorides and sulfates of calcium and magnesium. Hard water does not produce lather because the cations present in hard water react with soap to form insoluble precipitates. We know that soaps are sodium salts of stearic acids. So when soap is added to hard water, these anions combine with the calcium and the magnesium ions to form calcium and magnesium salts which are insoluble in water. For example, if I write a general reaction M2 positive. Now, M2 positive, it represents either Ca2 positive or Mg2 positive which are present in the hard water plus sodium stearate. This is a soap solution. Okay. Now here what happens? Here sodium ions get replaced by this cations, by the M2 positive cations, and we get this one. This one. Now these are the insoluble precipitates. These are the insoluble precipitates, whether Mb my calcium or magnesium. Okay. So hard water is unsuitable for laundry, washing and dyeing. In addition, hard water is also harmful for the steam boilers. Inner surface of the boiler gets crusted with scale known as boiler scale. Now it mainly consists of calcium sulfate, calcium carbonate and magnesium oxychloride. Deposition of scale decreases the efficiency of the boiler and also damages it. Therefore, hard water should not be used in boilers. Okay. Now we come to the type of hardness of water. First is the temporary hardness. Temporary hardness is due to the presence of dissolved bicarbonates of calcium and magnesium, which can be removed either by boiling or by calcium hydroxide method. Okay. Next, permanent hardness. Permanent hardness is due to the presence of dissolved chlorides and sulfates of calcium and magnesium. Now one thing you need to know, that chlorides of both calcium and magnesium are water soluble, but sulfate of only magnesium is soluble while sulfate of calcium is insoluble in water. Now permanent hardness can be removed by washing soda method and by ion exchange method, which is much applicable nowadays. Okay, so that's it, class 11. Next part we are going to continue in the next video. Thank you.